Today we are going to be talking about Unit 6.4, and we're going to be talking about inequalities in one triangle. So to start off with, we got to review from Algebra 1 our properties of inequality. So the inequality relationship between two real numbers is often applied in proofs. So recall that for any real numbers a and b, a is greater than b if and only if there is a positive number that that a would be equal to b plus c. So remember, the comparison property of inequality is just the fact that a is either less than b, a is greater than b, or a is equal to b. There is no other comparison we can make. The transitive property of inequality says that if a is less than b and b is less than c, then a also is less than c. And it works the other way as well, because if a is greater than b and b is greater than c, then a is greater than c. The addition property of inequality says that if a is less than b, if I add some number to both sides of that inequality, the a side will still be less than the b side. And the same is true in the other way. If a is greater than b, then if I add some number to both sides, then the a side will still be greater than the b side. The subtraction property of inequality works the same way, except in reverse, because if I subtract a number from both sides of an inequality, the inequality is still true. So the definition of inequality and the properties of inequalities can be applied to the measures of angles and segments, because these are real numbers. So we can use what we call the exterior angle inequality theorem to determine angles that are going to be greater than or less than certain angles. Remember that each exterior angle of a triangle has two remote interior angles that aren't adjacent to the exterior angle. So the way that is going to be used, trying to slide down here, list the angles that satisfy this condition. So first we're looking for the measures of the angles greater than the measure of angle 1. So measure of angle 1 is an exterior angle of triangle PQR. So angles PQR and PRQ as corresponding remote interior angles. So by the exterior angle inequality theorem, the measure of angle 1 has to be greater than the measure of angle PQR and the measure of PRQ. And because the measure of PQR is equal to the measure of angle 3 and the measure of angle 4, and the measure of angle PRQ is equal to the measure of angle 5 and the measure of angle 6, therefore the measure of angle 1 has to be greater than the measure of angle 3 and measure of angle 4, and the measure of angle 5 and the measure of angle 6 by substitution. So the angles with measures less than the measure of angle 1 are angle 3, angle 4, angle 5, angle 6, angle PQR, and angle PRQ. Now, the measures that are greater than the measure of angle 8, there is only one angle that we can prove is greater than the measure of angle 8, and that is the angle that is an remote exterior angle to angle 8, and that is angle 2. So angle 2 is the only one that we can prove, without a doubt, is greater than the measure of angle 8. So here is another example. We're looking for the measures that are greater than the measure of angle 1. Angle 1 is an exterior angle of angle ABC. So therefore, angle ABC will be less than the measure of angle 1. And then, of course, the measure of angle 7, which is BAC, will also be less than. And then also, since angle 1 is also an exterior angle of triangle BCD, we could say that angle 1 is going to be greater than the measure of angle 4. And it is going to be greater than the measure of angle 6. And then there's one more angle, of course, and that is angle 3. Because angle 3 plus angle 4 equals the measure of angle ABC, that means that angle 3 is also going to be less than angle 1. All right, so now, looking at the inverse of that, the measures that are greater than the measure of angle 7 is an interior angle of triangle ABC. So that means that the exterior angles of triangle ABC, like angle 2 and angle 1, are going to be greater than it. But there's another triangle that angle 7 is a part of, and that is triangle ADB. And triangle ADB has an exterior angle of angle 6. So that is why angle 6 is greater than angle 7. Now, angle side inequalities in one triangle. If one side of a triangle is longer than another side, then the angle that is opposite the longer side has a greater measure than the angle opposite the shorter side. So if one angle of a triangle has a greater measure than another angle, the side opposite the angle with the greater measure is longer than the side opposite the angle with the lesser measure. So the angles of triangle LMN in order from smallest to largest. The side that is opposite the shortest side, which is 5.4 units, which is side MN, would be angle L. So angle L is the smallest angle. Then the next longest side, side ML, the angle that is opposite that side, angle N, would go there. And then the longest side, side LN, the angle opposite that, angle M, it would be the next largest. And it works the opposite way too. If I know that angle W is 51 degrees, angle Y is 90 degrees, of course, because we have that box. So angle X is going to be 90 minus 51, or 39 degrees. So the side that is opposite angle X is going to be the shortest side. So that is side WY. The side that is opposite angle W is going to be the next shortest, so that is side XY. And then the hypotenuse is always the longest side, so that is side WX. All right. There's some more practice problems there at the bottom. I would love for you to go ahead and try to do those on your own. See if you can figure out which side lengths would be in order from shortest to smallest to largest, and then the angles that would be in order from smallest to largest, and then the side lengths there in the last two that would be in order from shortest to longest. All right, if you have any questions, please shoot me an email or a Canvas message, and I will get back to you as soon as I can. Have a great day.